Welcome back to CloudCast. I'm your network ninja, and today we're tackling a question I got wrong in a real production environment about 3 years ago. We had a multi-tenant SaaS platform, and I recommended VPC Peering to connect our customer VPCs to our service VPC. Seemed logical, right? Private connectivity, low latency. What could go wrong?
I'm guessing something went very wrong based on your tone.
Oh, it did. Our third customer had the same CIDR block as our service VPC, 10.0.0.0 out of 16. VPC peering flat-out refused to work because of the overlapping IP ranges. We had to re-architect the entire solution using PrivateLink, which cost us 2 weeks and a very uncomfortable conversation with leadership.
Ouch. So today we're learning from your pain?
Exactly. Today we're diving deep into AWS PrivateLink versus VPC peering. By the end of this episode, you'll know exactly when to use each one, and more importantly, you'll avoid the expensive mistakes I made. Welcome to the show.
Thanks for having me. So let's start at the beginning. Both of these are ways to connect VPCs privately, right? Why do we need two different solutions?
Great starting point. Both keep traffic on the AWS backbone network, never touching the public internet, but they solve fundamentally different problems. Think of it this way. VPC peering is like building a private road between two neighborhoods. Once that road exists, anyone in either neighborhood can drive to the other, assuming the local traffic rules allow it.
So with VPC peering, both sides have full network-level access to each other?
Exactly. It's a bidirectional, full mesh network connection at layer 3. When you peer VPC-A with VPC-B, you're creating a networking connection that allows you to route traffic between them. I should be precise here though. You're not literally merging routing tables. Rather, you're adding routes in each VPC's route tables that point to the peering connection as a target for the other VPC's CIDR range. Traffic can flow in both directions, and both VPCs can initiate connections to each other. The AWS documentation specifically states that peered VPCs can route traffic using private IPv4 or IPv6 addresses as if they're in the same network.
Okay, so what's PrivateLink then? How is it different?
PrivateLink is more like hiring a courier service. You're not building a road between neighborhoods. Instead, you're saying I have a specific service at this address, and I want to let people access just that service, nothing else. It's unidirectional and operates at layer 4, meaning it's connection-oriented to specific endpoints.
Wait, so with PrivateLink, the consumer can't just browse around the provider's entire network?
Correct, and this is crucial. With PrivateLink, you create what's called a VPC endpoint service on the provider side, which sits behind a load balancer listening on specific ports. Now, this used to be network load balancer only, but AWS added support for application load balancers as well. That's a big deal because ALBs give you layer 7 features like path-based routing, host-based routing, and better HTTP/HTTPS handling. The consumer creates an interface VPC endpoint, which provisions elastic network interfaces in their subnets. Traffic flows only from consumer to provider, only to the specific service, only on the ports the load balancer is configured for.
Oh, interesting. So you can choose between NLB and ALB now? When would you pick one over the other?
Great question. Use NLB when you need raw TCP/UDP performance, static IP addresses, or you're dealing with non-HTTP protocols. Use ALB when you want layer 7 features like content-based routing, WebSocket support, or you're building HTTP/HTTPS APIs and want features like sticky sessions or advanced request routing. The ALB support really opened up PrivateLink for more application-centric use cases.
That sounds way more restrictive than VPC peering. Why would anyone choose that over the flexibility of VPC peering?
3 massive reasons. First, remember my CIDR overlap disaster? PrivateLink doesn't care about overlapping IP ranges. The consumer gets a private IP address in their own VPC's range that maps to your service. Second, security. With VPC peering, you're trusting the other VPC's security posture because they have network access to your resources. With PrivateLink, you're exposing exactly one service endpoint.
And the third reason?
Scale and multi-tenancy. VPC peering has a default quota of 125 peering connections per VPC, though you can request increases from AWS. But even with increases, if you're building a SaaS platform with hundreds or thousands of customers, managing all those peering connections becomes operationally complex. PrivateLink can handle thousands of consumers connecting to a single endpoint service, which is far more manageable at scale.
Let me make sure I understand the architecture. With PrivateLink, I'd set up a network load balancer or application load balancer in my provider VPC, create an endpoint service pointing to that load balancer, And then my customers create interface endpoints in their VPCs.
You've got it. And here's a specific detail that trips people up. The interface endpoint creates any's in the consumer's subnets, and those any's get private IP addresses from the consumer's CIDR range. So if the consumer's subnet is 172.31.0.0 out of 24, the endpoint might get 172.31.0.47. The consumer's applications connect to that local IP, and AWS handles routing it through the PrivateLink fabric to your load balancer.
That's clever. The consumer never needs to know the provider's actual IP addresses.
Exactly. And you can enable private DNS on the endpoint, so the consumer can use a friendly DNS name that resolves to their local endpoint IP. No hard-coding IPs, no DNS complexity.
I should mention something I've seen in the docs. There are actually two types of VPC endpoints, right? Interface endpoints and gateway endpoints.
Great catch, and this is important context. Gateway endpoints are specifically for S3 and DynamoDB. They're free, they work by adding root table entries, and they don't use any's. Interface endpoints, which are what PrivateLink uses, work for everything else including AWS services and your own custom services. They use any's and have associated costs. When we're talking about PrivateLink for service-to-service connectivity, we're always talking about interface endpoints.
Okay, so when should I actually use VPC peering then? It sounds like PrivateLink wins in most scenarios.
Not so fast. VPC peering shines when you need bidirectional communication between VPCs you control. Think of a hub and spoke architecture where your shared services VPC needs to talk to application VPCs, and those application VPCs need to initiate connections back. Maybe your monitoring agents in the app VPCs need to push metrics to a central collector, and your deployment systems need to push to the app VPCs.
So if I own both VPCs and need two-way traffic, VPC peering makes sense?
Right. And there's a cost consideration, though I should note that AWS pricing changes, so always verify current rates. Generally speaking, VPC peering charges only for data transfer, and cross-OS traffic within the same region is relatively inexpensive. PrivateLink has both an hourly charge per endpoint per OS and a data processing charge. For high-throughput internal services, VPC peering can be significantly cheaper, but you'll want to run the numbers for your specific use case.
What about latency? Is one faster than the other?
VPC peering has slightly lower latency because it's direct routing between VPCs. PrivateLink adds a small overhead because traffic goes through the load balancer and the endpoint infrastructure. We're talking microseconds to low milliseconds difference, but for latency-sensitive applications like real-time trading systems, it could matter.
Let me throw a scenario at you. I'm building a microservices architecture with 5 VPCs, each running different services that all need to communicate with each other. What would you recommend?
This is where it gets nuanced. If you control all 5 VPCs and they have non-overlapping CIDR ranges, VPC peering with a full mesh gives you the simplest architecture. That's 10 peering connections for 5 VPCs, using the formula n times n minus 1 divided by 2. But here's the catch. VPC peering is non-transitive.
Non-transitive? What does that mean practically?
If VPC appears with VPCB, and VPCB peers with VPCC, VPC cannot reach VPCC through VPCB. You need a direct peering connection between A and C. This is explicitly stated in AWS documentation. So for 5 VPCs that all need to talk to each other, you need all 10 peering connections, not just 4 in a chain.
That could get messy with more VPCs.
It does. At 10 VPCs, you need 45 peering connections. At 20 VPCs, you need 190. This is where AWS Transit Gateway becomes relevant. But that's a topic for another episode. The point is, VPC peering doesn't scale elegantly for large mesh networks.
What's a common mistake you see people make when choosing between these two?
The biggest one is using VPC peering for third-party or customer connectivity. I've seen companies peer their production VPC with a vendor's VPC for easy integration. Now that vendor has network-level access to your VPC. Yes, you can use security groups and NACLs to restrict traffic, but you're relying on your firewall rules being perfect. One misconfigured security group, and that vendor can probe your internal services.
So PrivateLink would be safer there because you're only exposing the specific service they need?
Exactly. PrivateLink follows the principle of least privilege at the network level. The vendor can only reach the specific endpoint you've exposed, on the specific ports you've configured on the load balancer. They can't port scan your VPC. They can't discover other services. They can't accidentally or maliciously access resources you didn't intend to share.
Let's walk through a real implementation. Say I'm running a payment processing service and I want to offer it to other AWS customers via PrivateLink. What's the setup?
First, you deploy your payment service behind a load balancer. If it's a REST API, you might choose an application load balancer for the Layer 7 features. If it's raw TCP or you need static IPs, go with a network load balancer. Let's say it's an ALB listening on port 443 for HTTPS. The load balancer needs to be in the same VPC as your service, and you'd typically have targets in multiple availability zones for redundancy. Next, you go to the VPC console, find Endpoint Services, and create a new one pointing to your load balancer.
And then my customers can just connect?
Not quite. By default, Endpoint Services require acceptance. You'll see a setting called Require Acceptance for Endpoint. When a customer creates an interface endpoint to your service, you'll get a pending request that you need to approve. You can also whitelist specific AWS account IDs to auto-accept connections.
What does the customer need to do on their side?
They go to VPC endpoints in their console, choose Find Service by Name, and enter your service name, which looks like com.amazonaz.veps.us.123456789ABA-TEF0. After you accept their connection request, they select which of their subnets should have endpoint ENIs created. AWS provisions the ENIs, assigns private IPs from their subnet ranges, and they can start sending traffic to those IPs on port 443.
And if they want a nice DNS name instead of IP addresses?
You can enable private DNS for your endpoint service, but it requires domain verification. You'd need to prove you own the domain by adding a text record. Once verified, consumers who enable private DNS on their endpoint can use your domain name, and it resolves to their local endpoint IPs automatically through Route 53 Resolver.
This is really clicking now. Let me summarize what I've learned. VPC peering is for bidirectional, full network connectivity between VPCs I control, with non-overlapping CIDRs, where I need low latency and cost efficiency. It's like building a private road.
Perfect so far.
And PrivateLink is for exposing specific services to consumers, whether internal teams or external customers, where I want unidirectional access, support for overlapping CIDRs, and strong security boundaries. I can use either NLB or ALB depending on whether I need Layer 4 or Layer 7 features. It's like a courier service that only delivers to one address.
Nailed it. I'd add one more decision factor. If you're building something that might become a multi-tenant service or might need to connect to parties outside your organization, start with PrivateLink. It's easier to start restrictive and open up than to re-architect from VPC Peering to PrivateLink later, as I learned the hard way.
Any final gotchas to watch out for?
A few quick ones. First, PrivateLink interface endpoints are zonal. If you create an endpoint in US East 1A and US East 1B, but the provider's load balancer only has targets in US East 1C, you'll have cross-OS traffic charges and potential latency. Coordinate OS usage with your provider. Second, VPC peering route tables aren't automatic. After creating a peering connection, you must manually add routes in both VPC's route tables pointing to the peering connection for the appropriate CIDR ranges. And third, remember that gateway endpoints for S3 and DynamoDB are free and work differently from interface endpoints, so don't pay for PrivateLink when a gateway endpoint will do the job.
That's incredibly helpful. Thanks for sharing your battle scars so we can avoid them.
That's what CloudCast is all about. Remember, VPC peering for trusted, bidirectional, internal connectivity. PrivateLink for service-oriented, secure, scalable access patterns. Choose based on your trust model, scale requirements, and whether you control both ends of the connection. And always check current AWS documentation for the latest quotas and pricing. Until next time, keep your packets private and your architectures sound.